We got ourselves a 2021 Chevy Suburban. The car was purchased from the auction, obviously, got stickers, and it has a really bad hit on the back. The car crank no start. I did a pre-scan on it, and there's one code in the engine control module, P129F, fuel pump power control module, fuel pump speed signal incorrect. Stay tuned, I'm going to show you how to diagnose this with just a multimeter. Good day, viewers, and welcome back to Dallas Auto Diag. As you guys heard at the beginning, the engine rotation is very quick. So this is one of the signs that it's a fuel delivery issue. The other sign is the code that we have. And if you want to take it further, we can go to the engine control module and go to live data and watch the fuel pressure. Automatic transmission, there should be a fuel system data, low pressure, yeah, that'll work. Fuel pump command, percentage, fuel pump speed. Oh, what happened? We lost com with the PCM. Voltage 11.8. Interesting. It might be a scanner issue. Fuel pressure sensor right here. Let's check this out. Fuel pump speed and fuel pressure sensor, and crank it one more time. We have no speed and no pressure. So again, we kind of know already that it's a fuel delivery issue, but we just wanted to look at it, record some data, and I have collected some information for you guys, so let me share it with you. The three components that are involved in this situation: the engine control module, the PCM, there is a fuel pump power control module, which is located under the vehicle if it's a Cadillac, above spare tire, and if it's a Chevy or GMC, which what we have is on the left rear outer frame rail. And we have the fuel pump. Of course, it's in the fuel tank. It's a brushless three-phase AC fuel pump, so it's not a regular DC positive and negative fuel pump that you can activate using a 12 volt. This we can activate it, I think, using our scanner. We'll see if we have the active test in it. I think it is. And this is the location of it. In our case, I went and I tried to read system description. I did read, there is a lot of information, really good information about all the components involved in the fuel system delivery. However, the fuel pump control module doesn't have any known good values. We don't know what we're testing. So I'm gonna show you in this video what you should see and read on your voltmeter when you're testing one of these systems. When I go punch the code P129F, we have some information, but when we come to the circuit testing, it asks us to do continuity between the control module and the pump, just to make sure that there is no short between them or on the chassis. If there isn't, it basically says if there is, repair it. If there isn't, then replace the fuel pump control module. I think there's more to that, and to do this, we're gonna have to drop the fuel tank because the fuel pump is located above it. and there is no access to it from inside the vehicle. So what we're going to do here, we're going to check at the fuel pump control module. I already highlighted what we need to be checked. In every component we have inputs and outputs, so we're going to check the inputs and to see if this fuel pump control module has what it takes to work, to send a voltage out to the fuel pump to make it work. And if it does, that means the fuel pump is bad. So we have a couple of things. Let's go locate the module, remove the cover from the harness to be able to access these wires and take it from there. Fuel pump control module is located about between the two doors. On the side right here, this is the bracket for it. This is the pump. Again, this is a 2021 Chevy Suburban. This is the part number 13537053. And this is the harness. What do you do? It has a lock. You push the lock up, and then this red, the lock goes up, and then you press this piece, and then you try to open it up. This is how it opens. Let's remove this cover to have access to those wires. First input we're checking is this red wire, red and violet, pin number 7, and this should be power all the time. If the car is off or on, it should be power all the time. I'm using a regular test light. I'm hooked up to a ground. This is nothing but an extension from the battery, so you can use the chassis ground. You can use like this end of the test light to hook it to a chassis ground, and we're going to check this red one. And it doesn't matter if the module is hooked up or not. At this point right here we have a power. Let's check the other input. On the same setup, we still hooked up to a ground on one side, and the next one to check is this pin 16, violet and green, and we also should have power on it, except this with key on only. This is the wake up signal for the module to work. This is key on only. The third input we're checking is this ground, pin number 22, and it should be a black. And this time I switched my test light the other end to power. That's why I have this extension to have a good source of power. And this is the pin right here, the black wire, this thick one, and I'm back probe right here, and we have a good ground. Two more inputs to check. This pin number 15, blue, gray, and pin number 30, white. And if you look at the harness, these are the last two right here. We're going to check them from this side. Make sure do not shove anything bigger than this needle, because you're gonna end up separating those terminals over there, and that's gonna make a bad connection in the future. Now we are using a voltmeter. We're set to volt DC. We have our my green, which in your case is a black, hooked up to ground right here, to ground, and the red, we're checking those pins, and we should see an average of 2.4, 2.5 volts on both of them, around between 2 and 3 volt. Let me put it this way, between 2 and 3 volt, and usually around 2.5 volts. Now, is this the ultimate testing for those two pins? Of course not. The reason why there are communication lines, and there is a more advanced tool to use to test those properly. If you're seeing a 2.5, I think you are 70% to a good signal. However, there is another chance that those are the 25% left of that check-in to make it 100% good. But if you're limited on tooling, if you see 2.5, then you can assume that it is good. Let's now at this point, I think we finished our inputs. Now we're going to switch to outputs, and with the outputs we need the module, where is it, the module, to be plugged. if we have those inputs, all of them are there. Now, an easy clue of a bad module is not having the 5-volt reference right here. So this module gets a 12 volt from the battery. There is an output 5 volt to power sensors like the fuel pressure sensor, fuel level sensor, and some other sensors related to the fuel system. And right now we are probed on this pin number 12, brown and red, which is right here, and we still on voltage, DC volt. Our lead, the black lead, still on ground. And again, if you don't have this, you can connect it to the chassis, a good ground, and we're going to back probe without damaging the wire, and we should read around 5 volts. This is good. If you don't have 5 volts, if you have less than 4.2, or I would say 4 volts, that's a good clue that your module is bad. Now make sure your battery voltage is good. You have 11.5 and up. I would say 11 and up, but to be on the safe side, 12 and up is good for these testings. Now we have a 5 volt, we have another 5 volt I want to check, although checking one 5 volt could be enough, but there I saw another 5 volt I'm gonna find and back probe. The other 5 volt actually I missed. It is the one, the yellow and red, pin number 10, which is right here, and we do have a 5 volt here. Remember, we're doing all these checks with the key on. Vehicle key is on, and now we're switching to that gray, the pin number 8, and we're still on voltage DC. Our black lead still on the ground. The power is back probed on this gray, and we have 9 millivolt, which is near zero. We should have around battery voltage on this one, and also on the second one. It's a 3-phase, so the second one is the yellow and gray, which is the one next to it. And those are the thick wires, if you noticed. See, 2 millivolt. And the third one is this white and gray, pin 24. So it should be on the other side. White and gray. Found it right next to the yellow. And we have 3 millivolt. This is an indicator that this module is bad. It's not sending voltage to the fuel pump. Now this voltage is not the voltage that will run the fuel pump. We will go back to the gray to have a better probe, and when this module is good, you should see around 6 volts, not millivolts, 6 volts on your meter. And I'm about to crank it right now, which actually should send a signal to the fuel pump control module to run the fuel pump. See, we have nothing. Which means the key is on again. 10 millivolt, 9 millivolt, which means this fuel pump control module is bad. Let's see what else we have to check, or I mean, we can't stop at this point, but I just wanted to cover everything. We checked this, we checked this, the ground we checked, those we checked everything, pretty much. That's it. So this is how to test that code P129F using a just test light and a voltmeter. I'm calling a module. This module needs no programming. I don't see any programming sign on it, so this one is a plug and play. And hopefully this video helped you. I apologize for the tight spot. I've been waiting for an opportunity to get this code to film it for you guys. I've had it before, and I regret not to do it, but now I'm doing it. Hopefully this will help somebody diagnosing their truck correctly. Thank you guys for watching. If you're not a subscriber to the channel, please consider subscribing. If this video helped you in any way, please consider give me a thumbs up. I really appreciate your time. Have a good day.